Okay, sixth grade. Now that we went over our chapter 1 test, our objective today is to talk about area and perimeter. However, I do want to spend a little bit of time reviewing the properties, going over your homework from yesterday. Today's lesson, I think, is pretty easy, so we won't need too much time to go over it. If we have time, I would like to start the distributive property. If not, we're going to spend all of class on that tomorrow. That's when things start to get a little bit difficult, okay, when we get to something called distributive property, which, have you guys heard of distributive property? Okay, I just make it harder. Sean? Yeah, yep. All right, so you guys should have already checked practice 2.1. So I'm just going to start with, are there any questions? This was part of your warm-up today, was to check it. What questions do you have, Donatus? 7. Okay, how to do them? Okay, so number 7, you ready? So you're plugging in a squared. So we have 10 squared times b, which is -4, times c, which is -2 squared. So you have 100 times -4 times 4. How many negative signs are there? How many negative signs are there? You tell me. What's -2 squared? You know what I mean? -2 times -2, +4. Be very careful. When you're plugging a number into a variable that's already squared, if it's negative, it's going to be positive. Does everyone see that? Okay. That maybe that I didn't realize that would be tricky for you guys. Be very careful when you're plugging that negative into something that's squared. So Donatus, is that what you did on 8 and 9? Okay. Okay, so that's why your negatives were flipped a little bit. An answer key or blank? Okay. Hold on one second, guys. Oh, he tried to come in and then he left. I told him. Okay. I said his name. I was just checking homework. Okay. Okay, what other questions do you guys have? Mary. Okay, number 8. Let me just move this up. Okay, number 8, we have 23 times 5 times c squared. Ready? So what's -2 squared? Okay, so all you had to do was multiply from left to right. 23 times 5 times 4, and you get 460. Or you could have done 5 times 4 is 20, and then 20 times 23 is 460. So you could have grouped them differently if that was easier for you. Yeah. And then 115 times 4 is 460. Okay. All right. Okay, 11 you said, Mary? Did you say 11 was your next one? Okay. Are you okay if I erase? You're okay if I erase this, right? Okay, number 11, we have 9 times a squared plus 9 times b is -4, times 25. So that leaves us with 9 times 100 plus 9 times -4 is -36 times 25. 9 times 100 is 900 plus -36 times 25 is -900. And that, I know that's so little, but of course in math, it's annoying. If you miss that, the whole answer is going to be wrong. Yeah, that was tricky for number 11. Charles, is this on number 11? Go ahead. Yeah, yes, definitely. The reason I did it like that is I'm still trying to follow the order of operations from left to right. But if you guys prefer to group it differently, you may do that. Much easier. When I do mental math, sometimes I do that, group it differently. But when I teach you guys, sometimes I'll change things a little bit. But yes, go for it. It makes it much easier to multiply. I don't know who had their hand up next. Annalise? Okay, wait, let me go over the first page first, then we'll get to that. Yes, you always follow order of operations on anything you do in math. Yes. Adam. Okay, wait till I get to the second page. Anything else on 1 through 20? I just want to go over 1 through 20 first. Mary, were you okay on the other one? Yeah. Both of them, are you okay? Okay. All right, everyone's okay on 1 through 20. All right, let's flip over now then. Matt? Okay, is it okay if I move the answers? Okay, 25 gave us the area of an infield of a college softball field. It told us is 36 square feet. So what they gave us on the field is this side is 60 feet, this side is 60 feet. You need to convert that to yards and then find what the area is in square yards. So 60 feet is how many yards? Zach? 60 feet is how many yards? 20, good. So that would be same thing as 20 yards. That is the same thing as 20 yards. So how do you find the area now of the field in square yards? Justin? Good. We do 20 times 20. And how many yards are there? What's 20 times 20? Matt? Good. Yeah. They do tell you that's a mischief. You can't do that. You have to go back to the very first step. It's kind of like an order of operations. You have to take the sides, convert those first, then find the area. Okay? Yeah. That's probably why you guys messed up on that one. Donatus? Yeah. If you understand how to do it that way, you can do that. Do you want to explain your reasoning behind that? Yeah. I'm going to, in chapter 9 of this book, we will do problems like that way. I know. I know. That's a good thing. You guys are thinking outside of the box. I like it. Annalise. Okay. Yeah, that works great. Okay, how about 26 or 27? We're okay? Annalise? Yeah, did you understand they were having you convert from feet to yards? That's all you had to do. So you were just taking everything from feet and converting it to yards. You okay with that, Annalise? Yeah, but the first thing you do is take 60 feet, figure out how many yards that is, 60 feet, how many yards that is, and then to find the area in yards, you just take 20 times 20. Emma H. I'll just go back and show you them. Okay, Sean, were you okay with 26 and 27? Positive? Okay. Adam? I'll tell you the answers. Yeah. Before I do that, though, Sean? We're going to get to that. So, because I want to give you guys, I have a chart I want to show you. So, yeah, you're right. But give me some time. You guys are all ahead of me. We're going to do that as well. Adam, 21 is 81 feet. 22 is 160,000 meters. 23 is 9 minutes. 24 is 7 pounds. Okay. And again, we're getting to it. So you guys are just ahead of me. All right, anything else on the homework? All of you smart people out there. Doug? Yes. Yeah. How about, I'm surprised no one asked me about numbers 13 through 18. Are you guys okay with this? All right. Okay. All right, I mean, that's a good thing. I just anticipated that that would be the part you guys were confused on. Okay. All right, so thumbs up, thumbs down on that assignment before we go over the second one. Okay, thank you. All right, 2.1c. Number 1, Alyssa. Good, and don't forget you can abbreviate it as POM if you want. Matt, number 2. Good job. Identity, POA. Sean, number 3. Good job. So multiplicative property of -1 or -1 POM or property of -1. There are 3 ways to say that. You can pick which one. It doesn't matter to me. Annalise, number 4. Yeah, that's what Sean said. Yep. So commutative POA, commutative property of addition. Emma M, number 5. Good job. 0 POM. Charles, number 6. Okay, but there's a name for it. When you add opposites, you get 0. What is that property called? Nope. Nope. What are opposites? Yep. Inverse POA. Yeah, but the word for it is inverse. That's like Charles, isn't calling you Doug the same thing as calling you Charles? No. You have to call it its name. I'm just kidding with you. But no, it's inverse, Charles. Just because when you add opposites, you get 0. So that's like the definition of what you said. On a test, I don't know if I would mark that wrong or not if you put that. I'll have to think about that. So try to just put inverse, okay? Emma H, do you want to do the next one or do you have a question? Okay, go ahead. Good job. Number 8, Justin. It should just be 1. Yeah, it's POA because there's not multiplication. That's why I scratched. Let me see. Yeah, but so on number 8, sorry, you have 2x plus 3y plus z. There's no multiplication. Equals 2x. Okay, you're right. 2 times x is multiplication, but the way they are grouped, you're adding them. I can see where you guys got the multiplication, but the way they're grouped, yeah, and it should be POA because the way they're grouped is with adding, not with multiplication. If they were grouped and multiplication was between the groupings, then you would put POM. It should be POA. Yes, you're exactly right, Zach. It's how they're grouped, okay? Number 9, identity POM. Number 10, identity POM. 11, commutative POM. 12, associative POM. 13, commutative POA. 14, 0 POM, property of multiplication. Annalise. No, identity is when you multiply something by 1 and you get itself. Or there won't be. There won't be. Promise. Anyone else? Okay, thumbs up, thumbs down, thumbs down on that homework. All right, so pretty easy. Any questions in general on the properties, Sean? Good. Just like types of numbers, we're going to keep going over it. Remember how when we first learned types of numbers, it was a lot? We'll keep going over it. So, promise. Okay, let's go to page 3 in your notes. Examples 3, 4, and 5. So page 3 in your notes, you can put your homework away. Examples 3, 4, and 5. Charles, question, or do you want to help us with the first one? All right, first one, Charles. Good. Identity, and I'm going to abbreviate here a little bit. Property of multiplication. If you multiply something by 1, you get itself. Okay, how about letter B? Doug, it's on the board. Page 3. Matt? Good. Commutative, and I'm going to abbreviate, property of addition. The order that you add numbers or variables does not matter. Okay, Sean, letter C. Good. Can you explain why that one is identity? Good job. You still have itself. Just like when you multiply something by 1, you still get itself. When you add 0, you still get itself. Okay, Donatus, letter D. Nope. It does. That doesn't give me the answer, though. Good job. Associative what? Good job. So do you guys now see the difference between number 8 and this one? Number 8 had plus signs between how they were grouped. This one is just multiplication. They're all just next to each other. So that's how you know how they're grouped. What's between how they're grouped is how you know whether it's POA or POM. Charles? Yep. You do not. Yep, you're exactly right. You're exactly right. Yep. Yep, but you don't need to. And we can, if we're multiplying problems like letter D, we can group them however we want. Just like you mentioned on the homework, that it might be easier to multiply 2 things rather than the first 2, depending on what it is. Always. And that's what makes mental math much easier. Do it. Yep. Correct. Correct. As long as you multiply the first group, multiply the second group, and then add the products together. Doesn't matter. First. Yep. Yep. Annalise. Okay, you just need to remember identity property. Whatever you multiply or add to something, you have to get the original number. So whatever you multiply or add with the identity property, you have to get the original number. 1 times anything is still itself. 0 plus anything is still itself. 0 times something is 0. So that's the 0 POM. Because if you multiply something by 0, you always get 0. Okay? So you're just going to have to go over them, but we will keep going over them in class, just like types of numbers. Charles. Go ahead. Go ahead. Give it to me. Okay. So if you say it the other way, that would make me feel better. Okay, then I agree with you. Yes. And there are several properties that will use 2 of them. And yes, that could work. That's kind of on the border of, it could just be the 0 property. Yeah, I know. Yeah, I know. Adam, you may. Charles, yes, you are right. It's just like, yeah. I won't put a problem like that on the test where it could be 2. It'll just be 1 or the other. Okay? Briar. Yes, it could be. Exactly right. Zach? Yeah, that's a good way to write it. Yeah, you could do that. Okay, let's go to example 4 from the warm-up. Okay, rewrite each property using a commutative property. Alex, how can we rewrite this so that it still represents commutative property? Okay, you can tell us. N plus 6 is the same thing as what? Good job. So using the commutative property, flip them around. The order you add numbers does not matter. Justin, the second one. Good job. Okay, example 5, Sean, what did you put for letter A? Good job. So m plus, and then in parentheses, 5 plus 4. The associative property says the way you group numbers does not matter. Charles, how did you do letter B? Good job. Now you can, or you could also write it like this. So you could also write it like that, or you can keep brackets around it. There's a lot of ways you could. You're right. So did you leave yours like this? Okay, but what you said is correct. Annalise? That's fine. That's fine. Yep. Not if you have a 3T. No. I'm a M. Oh, yeah, definitely. Okay, I need you guys to flip your notes to page 4. Okay, this is an extension in your book. We've talked a little bit about area and perimeter, so we need to talk a little bit more about this. We're going to skip the warm-up that's in there because we did a warm-up today. So we're going to skip the warm-up that's in there. We're going to go right to the part that says perimeter. At the very top where it says perimeter, I want you to put units. Perimeter equals units. The very top where it says perimeter, I want you to put perimeter equals units. So when we're finding perimeter, it's either inches, meters, centimeters. It's not units squared, it's just regular units. We're going to start with the triangle. I want you guys to label the triangle A, B, C. Does anyone know why I had you label it A, B, C? Adam, do you know why? They could represent the units, yes. Now we've got a perimeter, but there's also another reason. Doug? Pythagorean's theorem. You guys heard of Pythagorean's theorem? A squared plus B squared equals C squared. C is always the hypotenuse. So typically you will see a triangle labeled this way, which is why I have you guys label it like this. That's typically the right angle. If you didn't know that, don't worry about it. I just want you to label it as ABC. So the perimeter of a triangle. How do you find a perimeter of a triangle? Briar, how do we find perimeter? So think about finding perimeter of a fence for your dog to put in your yard. Good. We need to add up all the sides. A plus B plus C. Now, do I care how you label the triangle at this point? No. You can label them however you want with whatever letters. The important part is that I want you to know to find perimeter of a triangle, you add up all the sides. Annalise? We're going to talk about it in chapter 9. So if you haven't heard of it, don't worry about it. I just figured I'd ask because you guys always seem to know things that we're getting to. So that's why I asked. You don't need to know it now, Annalise. Don't worry about it. Doug? Yep. Yep. Okay. Mary? They do. Yes. So if you want to put in there all angles equal 180, you can. Great job. All the angles in a triangle add up to 180 degrees. You don't need to know that yet either, but if you want to put it in there, you may. Justin? Yes. Yep. Yes. And you guys are doing very well. Yes. When I show you what Pythagorean's theorem is, we're going to do a little project. I'm going to show you kind of like what you just said. Wow, you guys are really impressing me. Okay. I should have you guys start teaching the lessons. We'll alternate. Okay, a square. What's one thing you know about a square, Briar? Good. All four sides are the same. Put little tick marks on each side to indicate each side is the same. Charles, what else do we know? Okay, but I'm gonna disagree with you. Good. Nope. Still gonna disagree with you. Go ahead, Charles. Fix your. Tell me why you said A plus A plus A plus A. Good job. Go ahead. Okay, you're ahead of me. Yeah, we're getting to that. So give me a second, because you're right. You're just ahead of me. Let me do perimeter first, then we're getting to area. So let's use S for a square. Again, it doesn't matter, but most of the time you'll see S as how a square is labeled. So we could have for perimeter S plus S plus S plus S. However, what's easier? That's kind of annoying. What's easier, Matt? Yeah, let's just do S times 4 for perimeter of a square. All the sides are the same. Take one of the sides, multiply it by 4. Annalise? Square. Square. Just like we did, we talked about area of a square. Gosh, I think it was the first or second week of school. We did area equals S squared. Mary? No, because to find area of a square, it's S times S. Perimeter is very different. 4 times S is not the same thing as S times S. Good point. Hold on, don't get too far ahead of me. Okay, so perimeter is regular units. You're finding the distance around. One other thing we know about a square is all the angles are right angles. Okay, all the angles are right angles. Briar. Good, and the lines are parallel. To indicate parallel, these little triangle things, these little arrows, that means the sides are parallel. That's also a geometry concept. You see those little arrows I drew? That means the sides are parallel. Briar, very good point. Okay, a rectangle. We know opposite sides are congruent, so I'm going to draw little tick marks. We also know on a rectangle all the angles are right angles. And I think it was Justin. Are you the one that told me it was 360 degrees? Okay. We know any quadrilateral, any polygon with 4 sides has 360 degrees in it. So we know that's true for both of those. Now, a rectangle we're going to label as length and width. Okay, length and width. So how could we make a simplified formula for finding perimeter of a rectangle? Sean? Awesome. Yep. No, all 3 angles add up to 180. And that's not an important thing for this chapter, Sean, but we're going to get to it. I wrote it there because someone brought it up. Emma M., you're welcome. That's area. So perimeter of a rectangle, add up all the sides. So 2W plus 2 out. Doug. That's in chapter 10. You're way ahead now. Okay, let's try to stay on this. Any questions on perimeter? Okay, take it down a couple of notches. Man, I'm going to be getting through a lot with you guys. All right, let's do area. Flip over your notes. Okay, now Charles brought up in regards to finding area, can we use A and B? You can use A and B for area, but the more common formula that you are going to see for a triangle still uses the B, which in this case represents base, and it uses H, which represents height. Not to throw more letters at you, but I want to keep it the way you're going to see it on any standardized test, in any book, in any math class, from any teacher. Yeah, on any piece of say. So Zach, how do we find area of a triangle? Do you know? Good. So there's 2 ways to write this. Area is equal to 1/2 base times height, or what's the other way we could write that? Adam, what's the other way? Good. Base times height divided by 2. For the past 4 years I've been teaching this class, for some reason, most students in this class prefer to write it this way. So raise your hand if that's true. Do you prefer this way? Right here. Okay, that's interesting. Can someone explain to me why, Adam? Okay, because I always prefer this way. So I was just wondering. However, because most people prefer this way, I will do all the problems on the smart board this way. But I just was always curious as to why. Okay. But all you're doing, though, here's why I don't get it. All you're doing is taking half of the base. But maybe you guys just think fractions are confusing to begin with. Okay. Alyssa? That's why. Thank you. So that's the real reason. Thank you. Okay. So area of a triangle, 1/2 base times height. Base times height divided by 2. Units are always units squared. So make sure next to area, you have units squared. If you guys have your hand up, is it a question about this? Mary? Mm-hmm. That's what I do. Yeah. Annalise? This is the same thing as this. Okay. So, Adam, do you want to explain it? Go ahead. Yep. Okay, listen, okay, Annalise, listen. Base times height is on top. Any whole numbers in the top. If you put a 1 on the bottom, 2 times 1 is 2. Base times height times 1 is base times height. Don't listen to that. Listen to this. Adam, you're correct. You are exactly correct. But all I want to explain to you, Annalise, is why these formulas are the same. So 1/2 times base times height. 1 times BH is the same thing as 2 times 1, which is 2. Okay, that's not part of this class right now. All you need to know is that's the formula, okay? We're not proving formulas, that's geometry, okay? All right, square, go ahead and label your sides as S, 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 S. Okay, how do we find area of a square? Area of a square, Alyssa? Good, area of a square is side squared, just take side times side, we get side squared. Okay, a rectangle we always label as length and width. It doesn't matter where you put the L, where you put the W, as long as they're across from each other. How do we find area of a rectangle? Charles? Good, L times W. So again, we're not proving formulas. I just want you to know the properties of these figures, and I want you to know what the formula is. Eventually, you'll prove formulas, but that's not until geometry. Okay, Doug? Do you remember? What did we do in class? Yeah, that's what we did in class. Yep. Okay, because of time, I'm going to jump ahead to example 3. Emma? Volume. Yeah, units cubed is for volume. Great question. Okay, because of time, I want to do one example with you guys, and I'm going to use the triangle to do the example because the square and rectangle are pretty easy to find perimeter and area. Do you guys agree? Okay, so let's do the triangle, and let's start with finding perimeter. So I'm just going to use a capital P to represent perimeter. How do we find perimeter of this triangle? Adam. Good. 15 plus 20 plus 25. What property that we learned yesterday could we use on this? What property could we use, Briar? Good. What other property could we use? Emma H? Good. Associative. What 2 numbers would be easiest to add first? Oh, lots of hands. This is awesome. Sean? Okay, 20 and 25, you get 45, and then add on the 15. Yeah, I would do, and this, you guys might disagree, but I would probably do 25 and 15 first to get 40, and then add the 20 in. You know what I mean? Just because you're working with a nice number. But all of our brains work differently, so if you guys think combining 2 other numbers is easier, go for it. What kind of 60? What kind of 60, Justin? Good, inches. Your units for perimeter are always just regular units, so in this case, just inches. If you don't have units, you're going to miss points on your next test. Make sure you have units. Charles? Okay, you're way ahead of me. Okay, hold on. Charles, let's go back a couple steps. Tell me what the base times height is. Tell me what the numbers are, though. What is the base? Good job. So base times height, we're just going back a step, divided by 2. Area of a triangle is base times height divided by 2. Multiply the top, divide by the denominator. So this is kind of like what Doug was asking about. So Charles, remind us again, what was your answer? Good, 150 inches squared. Area is always units squared. Perimeter is always units. Mary, is that a question? Well, that's how I do it, but I didn't want to confuse you. So if you guys do it the other way, which is area is equal to 1/2 base times height, that would be 1/2 times 20 times 15. Half of 20 is 10. 10 times 15 is 150. That's why I like this way better. You don't need to do it this way. There's 2 ways. If you guys are more comfortable with this way, use this way. I'll explain one more time. I like this way because half of 20 is 10. That's what I do. It's kind of like saying 20 divided by 2 is 10. 10 times 15 is 150. Yes, because of the properties. Because of the associative or commutative property, depending on how you look at it, you are allowed to do that. Great job, Adam. Charles. Yes, go ahead. Briar. Yes. If these are not like even or not nice numbers, I would say do not do it this way. I would say do it this way. Yes. Because especially when you guys get to geometry, the numbers are going to get pretty crazy. Radicals, decimals, irrational numbers. So yes, this is just a very basic overview of what the formula is and how to use it. Yeah. It could be 2 square root of 7. Actually, you guys were ahead again, but chapter 9, I'm going to show you special types of triangles. And you'll see that. They're called special right triangles. Annalise. Same way. Same way. As long as you're using the height and the base, same way. Right, doesn't matter. Mary. Yeah, I know, but 25 is the hypotenuse. You always need to use the height and the base. Sean. Yep. Okay, hold off on your questions, guys, because I need to explain homework. Okay, so in your notes, you need to finish numbers 1 and 2. So notes, page 5, numbers 1 and 2. And then in your book, on page 70, so write this down somewhere, you need to do numbers 1 through 8. So let me explain this. Yeah, let me explain this again. Notes, page 5, so where we just were, please finish numbers 1 and 2, because I wanted to in class, but we don't have time. In your book, page 70, 1 through 8. There's one problem that looks like this. This would be number 6. What is the base of that triangle? You probably should know. I just figured I should talk about it. What's the base, Donatus? The base. Good. The base is 10. What's the height? Zach? 6. So on number 6, when you see that, the base is 10, the height is 6. Okay, so before I have you get a book, is everyone clear on what the assignments are? If your test is not signed, bring it back tomorrow, except for Donatus. Mary? Yep, this is in the book. Nope, this one's in your book. You may use the online book or take your book home. 2 of you, well actually one of you still needs to get your book covered. Please do that. That should have been done a long time ago. So notes and book. Zach? Yeah, but they all correspond. So if you go to page 70, it'll be the same assignment. Charles, are you okay with the assignment? Yep. Okay, guys, you can